This is the can opener. I'm Jordan.
I'm Raj.
I'm Zach.
So the function of a can opener is to open a can, believe it or not, and it does this with a rotating blade and something to hold the can in place. There's two levers that kind of pinch together to grip the can, and then a wheel that with a crank that acts as a wheel and axle to give you mechanical advantage so that you can twist, open, and cut through the can while also rotating the can around the blade while you go. So these are the photos of the parts of it put together from both sides, and then these are all of the parts taken apart. We made this part, the main body that holds it, the crank, and then the blade, because those are the three most functional base parts, we thought. These are sketches of all of those. Again, this is the body, the crank is up there, and then the main blade is that one. So this is the blade up close. Just so you know, the actual blade part we found to be a different material. So some of the numbers for the density might be a little weird. That's because this part is a normal stainless steel, and this part is a much harder, possibly like tempered stainless steel, or no idea. So this is our dimension drawing. It's kind of hard to see with the resolution of the projector, but this is the side of it, and then two views from Inventor. And we weren't terribly close on guessing its properties. So now to talk about the next product, or part.
Yeah, this is the crank. This is the thing you like turn to spin the blade to open the can. That's what it looks like in Inventor. The measurements aren't completely perfect, but it's close enough. This is the dimension we'll give you of it. And these are our eye properties for it.
Okay, so this is the main body piece used to hold together most of the parts. We have our inventor view and our dimension. Then we have an eye properties with our density still really for most other pieces, but surface area is pretty close. It's off by 500-ish.
So this was really a good project, and we thought that one thing that was important is that it's a very interconnected system. All of the gears work together. There's a lot of stuff that goes together, and so it would be difficult to work without collaboration. So it's a good collaboration building effort. And also, there may be some errors in some things just because they weren't quite, they were kind of bent out of place, because separating was a pretty big task that involved a lot of force. And so some of the parts were bent out of shape, and we just kind of guesstimated.
We gotta bend them back a little bit.
And we also used a hammer.
What did you put in for the materials in Inventor?
Stainless steel.
Stainless steel.
And then the blade, I just put in all the stainless steel because I didn't know how to make one chunk different.
So the inventor would have told you then what the density was based on what you decided. So
basing on the casing on the outside of the stainless steel, not the blade, which we assumed was something a little.
So what was the density of the stainless steel?
I do not remember. The calculated density that we got from going down to Miss Goldman's
was
7.4, and then the thing that it just told us it was this for just the
was 8.
Was 8 for just the generic.
That's not that bad.
For just the generic stainless steel that we chose.
Was there different types of stainless steel in Inventor you could choose?
Yeah, I didn't know what they were really.
We just picked the basic one.
Right.
We just figured that this was a generic household.
You could have picked the one that was closest to 7.44.
I believe this was the other ones.
Well, we thought it was more of a basic stainless steel, not some advanced stainless steel that was closer to 7.44.
Oh,
we figured being a basic product, it would have the cheapest and most likely the most basic type of steel in production. So we thought that would be the safest bet and the most accurate bet.
All right. Any other questions about recyclability of any of these things, parts and stuff?
Manufacturing.
Yeah, manufacturing.
Manufacturing.
Yeah, where's the guild?
Zach, where's the slide for that?
Must have been lost in the.
So the
no recyclability.
If we
stuff?
go back to our image slide with all the pictures of parts on it, we're going to these were probably cut from a sheet of stainless steel and then probably hole punched with stuff, and those are probably made from like a big sheet that is folded by a machine. These were probably cut like on some sort of like a lathe, like a metalworking lathe that does a bunch of them, and then a robot that probably puts it all together. These are like the inside is plastic and then the outside shell is a rubberized plastic. So they were probably injection molded in two separate parts, with the inside being injection molded and then the outside being put on around it. We think they're bonded by epoxy, not by actually being like a part of it. So it's probably just put on afterwards. And then also on some of these internal ones here, some of the little pegs that stick out, you can see a seam where it's been either just very strongly attached or welded, and then just the excess has been ground off. So they are attached and probably designed in separate portions and then reaffixed back together for the manufacturing. This is a rubberized plastic that might be recyclable. You could try putting it in a recycling bin, and the stainless steel you can melt, but it might have some kind of a varnish, and also the blade is two different kinds of metal, or at least one part is tempered, which might affect your recycling process. Yes, Adam?
What was the cost?
Pulled that out pretty good.
This item here.
No, I had this planned. I just forgot. We forgot to put the slide on.
I see.
Yes.
Sir,
We did our research.
Zach is going to tell you about the cost of this item.
tell me
because
the
it was
cost.
his.
Generally, the cost of a can opener of this quality and stability is around $10 to $12, depending on where you're getting it. If you want
New
more
from a
cheaper,
store, you could go to a garage sale probably, find it for like $1,
Whoa,
maybe.
that sounds like a deal.
Could happen.
Sometimes they find that
true.
15.
Okay, anything else? All right, good job.
It also has Wi-Fi and
This
USB-C.
is an industrial.
I don't think it's like Wi-Fi.